So now we're going to look at how black body radiation works. So this, again, builds on the video about oscillation. So you can see how changing the speed, accelerating charges, electrons, create kinks or disruptions in the emanating electrical field wave patterns. And that's how we get EM radiation. So it's great to look at that video first, so to understand what's going on here. So now we just have a few electrons then in a material, and they're moving very slowly, and then we're going to start moving them more quickly. So we're going to start heating it up, and then you're going to see them move more quickly, and then we add a few more electrons, and then you're going to see that every time they change direction or speed, accelerate, also because they are repelling each other, you will get electromagnetic radiation. So then if we start heating up more, we can also make it a little bit smaller here. Let's see, putting high density. Then you see how they just physically move around, and when they move around and bump into each other, they constantly will emit electromagnetic radiation. So you can see here now on the right side, you see the black body spectrum. So every different kind of changing, like acceleration, will create a different, like you would say, photon or electromagnetic kink in their constant emanation. And the distribution of all these frequencies on the kinks is the distribution of photons. If you want to think of it as photons, if you want to quantize, meaning put a grid on the variation here of these emanations, then you will get this black body spectrum. So you can see if we move this further up, then now at 4,000 degrees, the material, if this is a block of iron or a metal, it will start glowing. So you can see this from the beginning, as you could say, first something gets red, and then it gets yellow, and then it will be more and more white and kind of bluish at the end. But if you have it 4,000, then you see they move around more quickly, even more if you add more. And then you see all these different motions. And then for fun, around 6,000, this is the sun, the surface of the sun, at least to be precise. That is the black body spectrum that we observe from the sun. And you can notice here, because technically all the black body spectrum we have here shows is the distribution of changing speeds of electrons. So we convert this usually to say that means the temperature of the material is this specific amount. But in reality, what it says is, again, how are all these electrons moving around and bouncing into each other, and how quickly are they accelerating every time they change their direction or their speeds. So you can see it here if you have it even smaller, and then it's also nice with a good more red color. If you have lots more of them, you see this beautiful little visualization here of what happens with the black body spectrum. And then you can again see the curve here, how that works. So if you just out in empty space as well, if you have a certain amount of electrons floating around, bumping into each other, they will generate this kind of distribution of photons of the electromagnetic spectrum. So that's all we wanted to show in this video, just how oscillations or motions of electrons create this variety of photons and emanating. And then if it is in a material, then the material will start glowing, and then you can see even more so if you do it up here, and we can say, just play around with this, also removing the sidebars, and then you can just see how just the variety and intensity you can quickly create by heating up something and create more motions with all the electrons. So that's all for this one. I'm going to put it back to the natural sunlight around 6,000 and ramp up number of electrons as well. So that's actually what we observe if you look at the sun. That's what you're going to see with the light is generated by exactly this phenomena. Okay, so that was all for this one. Thank you so much for watching, and we'll be back very soon with another video. Bye bye.